Hello everyone. In this tutorial, we will look at some of the basic concepts of network theory, also called as the circuit theory. So we will begin with the basic network terminologies. The first one would be the circuit. So circuit is an interconnection of elements, that is the network elements, which are sometimes also called as the circuit elements. Circuit element will have the presence of the individual electrical components like resistor, capacitor and inductor, and we can also have the current and the voltage sources which are present between the terminals. Now, based on the capability to generate the energy, these circuit elements can be classified as active elements and passive elements. The active elements are the ones which are capable of delivering the energy to the external devices. So these basically deliver the energy, while the passive elements are the ones which are capable of only receiving the energy or the power. So these will either only receive energy or power. So if I have to give you some examples, for active elements we have the voltage sources that we have seen, current sources, we have the transistors, diodes, LEDs, photodiodes, integrated circuits, op-amps. We have displays like the 7-segment display, and we can also have the batteries, which are all active circuit elements which will deliver the energy to external devices. Coming to the passive elements, example can be the resistor, capacitor and the inductor. Then we have the switches. We can have the variable resistors, so symbolically I am representing here. We can have transformers, we can have thermistors, we can have LDRs, okay. So after this, let us continue with the most important basic terminologies. So the first one would be the node. For that, let me consider a simple circuit here with voltage sources V1, resistance R1, R2, and resistance R3 with another voltage source V2. So this is my circuit that I have. So the first terminology that we will look into is a node. So node is basically a point in an electrical circuit where two or more circuit elements are connected. It basically serves as a junction point, but here mainly it is the two or more circuit elements which are connected. So you can see I have voltage V1 and voltage V2. Then I have resistances R1, R2 and R3. So here resistance R1 and R2 and R3 meet at a node. Similarly, voltage V1 and R1 meet at a node, and voltage V2 and R3 meet at a node. So in this case, it is a point where two or more circuit elements meet. We can also tell it in terms of branches as where two or more branches meet. So here R1, R2 and R3 meet at one particular point, that becomes a node. So when it comes to branches, first I will give you the definition of the branches later, and then it will be much clear as to what I am discussing here when I say two or more branches meet. So let me just mark the nodes that are available. So this is my first node, second node, and I have the third node, which is between R3 and V2, and the below one will be the fourth node. So I have highlighted my nodes. So in total I will be having 4 nodes in this particular case. Let us look into the second definition, which is a junction. Junction basically is a point where 3 or more elements meet. So there is a difference between a node and a junction. In a node it is 2 or more circuit elements, whereas here it is 3 or more circuit elements. The same definition can be given in terms of branches as where 3 or more branches meet becomes a junction. So if you see at node 2, I have resistance R1, R2 and R3 which is meeting. So node 2 can also be a junction. So we also have node 4 where V1, R2 and V2 meet, so that is another junction. But one important concept you should know is that not all nodes are junctions, whereas all junctions are nodes. So remember this concept. Moving on, let us look into the third definition, which is the branch. So branch is basically a part of the circuit which is present between the two nodes that can either deliver or absorb energy, excluding the short circuit. Okay, so short circuits are not a part of the branch, but a branch is a part of the circuit which is present between the nodes that can deliver or absorb energy. What this means is that we have seen whenever you have an active element or a passive element, it can deliver or absorb energy. So wherever you have a circuit element present, it becomes a branch. So if you observe here, we have V1, R1, R2 and R3 and V2, which are all circuit elements which are either delivering or absorbing energy. That is why they all become a branch. That is why in the definition of the node and the junction we saw, where 2 or more branches meet, it becomes a node. Where 3 or more branches meet, it becomes a junction. So we have one branch which is V1, another branch which is R1, the third branch is R2, fourth branch is R3 and the fifth branch is V2. So in this particular circuit, if you see, we are having in total 5 branches. So 5 branches means 5 circuit elements are present. So if I have to go to the nodes, let me just list them. I have node 1, 2, 3 and 4, whereas junctions are 2 and 4. So I'll give you another circuit for you to identify whether there is a branch or not a branch. So let me draw a circuit with a current source and few resistances connected in parallel. So let me name these resistances as R1, R2, R3 and current sources I1. So if you see here, wherever a circuit element is present, that would be a branch. So I1, R1, R2 and R3 are branches. Whereas if you see these two nodes, okay, the nodes that are present at the bottom, they do not have a circuit element in between. So this will not be a branch because no circuit element is present. Similarly, if you see on the top, between the two nodes here also you do not have any circuit element, so it is not a branch. And if you see in the last one between the two nodes, it's more like a short. No circuit element is present, so it is not a branch. So the number of branches will always be equal to the number of circuit elements that are present in the circuit. Now let us look at the fourth concept, that is the loop. So loop is basically a closed path in the circuit where one returns to the starting node without crossing any intermediate node twice. Okay, so it is, let me repeat, it is a closed path in the circuit where one will return to the starting node without crossing any intermediate node twice. Then we have another definition which is called as the mesh. Their meshes are also sometimes called as the independent loops. So independent loops is basically a type of a loop that is not containing any other loops inside it. So basically this is the smallest closed path in a circuit, or we sometimes also say it as the elementary part of the circuit. So let me just draw one simple circuit to explain you the loops and the meshes. So in this particular circuit, I am considering a voltage source V1, 3 resistance R1, R2 and R3 and another current source which is I2. Let me highlight the loops first. So we said loop means it will return to the starting node without crossing any intermediate nodes twice, right? So let me mark that in the red color. This would be one particular loop which I have. If I'm considering the starting point between V1 and R1, so I'm going to start from there and return back to the same point. So let us list that. Before that, let us name all the possible nodes so that I can write the loop list. So loops would be, the first loop that we identified is A, B, C, D, E, F, G, H, A, starting and ending at the same node. So then you have another loop which is A, B, G, H, A. The third loop, which is B, C, F, G, B. The fourth loop is C, D, E, F, A, E, F, C. Then we can also have A, B, C, F, G, H, A, and we can have another one as B, C, D, E, F, G, B. Now coming to the meshes. Meshes are basically elementary part of the loops which do not contain any loops. So we have already marked here. So here the independent loops would be A, B, G, H, A, B, C, F, G, B, and C, D, E, F, C. So let us list them. So those are the independent loops that are not containing any other loops. So one important aspect you should remember is that here in this particular circuit we have 3 meshes and we have 6 loops. So the important aspect to remember here is that the meshes are sometimes interchangeably called as independent loops, and we should remember that the meshes are nothing but loops. So meshes can be loops, but not all loops are meshes. So if you have understood all these concepts, let us try to solve one simple circuit wherein you have to identify the number of nodes, the number of junctions, the number of branches, the number of meshes, and the number of loops that are present in the circuit. So let me consider one voltage source of 10 volt, resistance of say 5 ohms, another resistance of 4 and another resistance of 3 ohms, and one current source of say 2 amps. Okay, you need to identify these basic terms that we just learned in this tutorial today. So let us look at it one by one. The first thing is the number of nodes. So let us mark it. Now one important aspect you should remember is that whenever there is no circuit element between the nodes, we can club all those nodes as one. So if you see here at the bottom, there are actually 3 nodes, but we can club them and it together becomes one single node. So in this particular circuit, we are having in total 4 nodes. So you have this one to be the first node, this is the second, this is the third, and the fourth one is at the bottom, which is clubbed together, and this is the fourth node. So the number of nodes is 4, and the junction that you see is 2 junctions. I will write the nodes 1, 2, 3 and 4. The junctions are 2 and 4. And then we have to mention the branches. Branches, as we discussed, corresponds to the number of circuit elements that are present in the circuit. So that would be, we have 10 volt, 5, 4, 3 and 2, which is equal to 5 branches. Then meshes, clearly we have 2 meshes which are corresponding to independent loops, that is equal to 2, and loops can be 2 meshes and one outermost one, which is going to be equal to 3 in total. Okay, so generally whenever a circuit is given, they ask you to verify the fundamental theorem of network topology. So just let me write the fundamental theorem of network topology, which is equal to B, which is equal to L plus n minus 1, where B corresponds to the branches, L corresponds to the independent loops or the meshes, n corresponds to the number of nodes. So in this example that I gave you, we had 5 branches. So on the left hand side, B can be equal to 5. L corresponds to meshes, which is equal to 2, and nodes is 4 minus 1. So on the right hand side also we get it as 5. So LHS is equal to RHS.